projects. In this video, we are going to explain about the project, which is Twitter hate speech detection, a systematic review of methods, taxonomy analysis, challenges, and opportunities. Introduction of the project. Over the past decade, social media platforms like Twitter have experienced exponential growth, with Twitter alone boasting 300 million active monthly users. However, this surge in popularity has also given rise to concerns about the spread of hate speech facilitated by user anonymity and the promotion of freedom of speech. Despite its popularity, Twitter has become a prominent platform for the dissemination of hate speech, leading to real life conflicts and negative impacts on users and businesses. Social media companies have responded by deleting hateful content, but the manual filtering process is deemed inflexible, prompting a need for automated solutions. So, this project narrows its focus to Twitter text in English due to the language's global prevalence and the availability of the abundant data. The increasing challenges associated with identifying and addressing hate speech on social media, particularly Twitter, have spurred research in the field of natural language processing and machine learning. Automation is considered imperative to enhance detection speed as manual methods lag behind the pace of computer based solutions. The project's focus is to develop a robust system for detecting hate speech in tweets using a systematic approach. Leveraging a diverse set of machine learning and deep learning models, the system seeks to analyze and classify tweets as hate speech or non hateful. Objective of the project. The primary objective is to create a machine learning system that is capable of precise identification of hate speech within tweets. The aim is to contribute to the ongoing efforts aimed at minimizing online harassment and fostering a safer digital environment. The goal is to explore a diverse range of machine learning models, spanning from traditional algorithms to advanced deep learning models like BERT, BILSTM, and GRU. The objective is to understand the effectiveness of these models in detecting hate speech across various forms of textual content. The project aims to investigate and apply ensemble methods. The objective is to leverage the strength of individual models to enhance predictive performance and establish a more robust hate speech detection system. The aim is to apply latent rightlet allocation for topic modeling, extracting additional insights from the text data. The objective is to gain a deeper understanding of thematic content within tweets, going beyond binary hate speech classification. This project benefits social media platforms, online communities, and regulatory bodies. By proactively identifying and addressing hate speech, it contributes to a safer and more positive online environment. Users experience reduced instances for harassment, and regulatory bodies gain valuable tools for enforcing policies against hate speech on digital platforms. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this initial step, the project begins by importing essential Python packages and libraries that are required for the project. We imported pandas for efficient data manipulation, matplotlib and seaborn for visualization, scikit-learn for various machine learning tasks, TensorFlow and Keras for deep learning models, Flask for web development. Exploring the dataset. This step involves loading the dataset containing tweets and conducting a thorough exploration. The dataset structure is examined, potentially missing values are identified, and in-depth analysis of class distribution, which is hate speech versus non-hate speech, is conducted. Insights into the valuable available features within the dataset are also gained. Coming to visualization, sample outcome, which is a subsequent exploratory step, the project visualizes a subset of outcomes from the dataset. This provides a clear representation of the distribution of hate speech and non-hate speech instances. Word cloud. A word cloud is generated to visually depict the most frequently occurring words in the dataset. This technique offers a quick overview of the prevalent terms. Data processing. In this step, the text data is pre-processed by eliminating URLs and unwanted characters. Punctuation marks are stripped from the text to focus on the content of words. Commonly used stop words are removed to enhance the relevance of remaining text. The data is normalized, potentially involving the conversion of text to lowercase. Linguistic techniques such as lemmatization and stemming are applied to reduce words to their base or root forms. Tokenization. Here, we have used Count Vectorizer. Count Vectorizer is a text processing tool that converts a set of text documents into matrix of words, facilitating the numerical representation of textual data for machine learning models. It involves tokenization, counting the occurrences of each word and creating a sparse matrix where rows correspond to documents, columns to unique words, and values to word counts. So here, the text is transformed into numerical vectors using Count Vectorizer, a technique that represents bag of words model. Keras tokenizer. Text is tokenized specifically for neural network models, leveraging the Keras library. It facilitates the transformation of textual data into a format suitable for deep learning models. The next tokenizer is BERT tokenizer. The BERT tokenizer used in conjunction with BERT-based models employed word-piece tokenization and contextual information to process text bidirectionally, capturing nuanced linguistic relationships for improved natural language understanding in NLP tasks. It breaks down words into subword units, enhancing flexibility in handling vocabulary, and considers both preceding and following the words to create contextualized representations. Tokenization is performed specifically for BERT models, a state of the art transformer based approach. The next step is feature selection. In this phase, relevant features are identified and selected for subsequent model training. The next step is splitting the data into train and test. The dataset is divided into distinct training and testing sets. The training set is employed for training the model, while testing set is reserved for evaluating model's performance. Coming to building the model. This is the critical step which involves the actual implementation of various machine learning models and deep learning models. Training the model. The models are trained using the designated training dataset, allowing them to learn patterns and relationships within the data. Flask framework with SQLite for sign up and sign in. The project transitions to building a web application using Flask, a web framework in Python. SQLite is incorporated to manage user authentication, including sign up and sign in functionalities, ensuring a secure user experience. User gives input. User interact with the web application by providing input, typically in the form of text. Input preprocessing for prediction. The user input text undergoes preprocessing steps similar to those applied during the training phase, ensuring consistency and accuracy in the subsequent predictions. The next step is trained model is used for prediction. The preprocessed user input is fed into the previously trained machine learning models, which then predicts whether the provided text contains hate speech. Applied LDA model for topic modeling. The project applies latent dirichlet allocation, which is LDA, which is probabilistic generative model in natural language processing used for topic modeling, where it assigns topics to documents based on the distribution of words, uncovering latent thematic structures within a corpus. Here, LDA is used for topic modeling on the user input text. This step aims to extract latent topics present within the text beyond a binary hate speech classification. The last step is final outcome is displayed through frontend. The results of the model predictions and topic modeling are seamlessly integrated into the web application's frontend. Users can visually assess the outcomes, providing them with valuable insights derived from the model's analysis. Now we will know what are the algorithms used in the project. The first algorithm is BERT, which is bidirectional encoder representations from transformers. BERT is a transformer-based neural network architecture designed for natural language processing tasks, which is NLP tasks. It uses attention mechanisms to capture contextual information bidirectionally, allowing it to understand the meaning of words based on their context. BERT is employed for its ability to capture complex linguistic patterns and contextual relationships in the text, making it effective for hate speech detection where understanding the context is crucial. The next one is BiLSTM, which is bidirectional long short term memory. It is a type of recurrent neural network that processes input sequences in both forward and backward directions. It captures long term dependencies in the sequential data. BiLSTM is used to model sequential dependencies in the text, making it suitable for understanding the sequential nature of language in tweets. GRU, it is gated recurrent unit. It is a variant of traditional LSTM, which is long short-term memory architecture designed to simplify the structure while retaining the ability to capture sequential information. GRU is employed for providing an efficient alternative for capturing sequential dependencies in the text. CNN, which is Convolutional Neural Network. CNN is a deep learning architecture commonly used for image processing but adapted for text analysis. It uses convolutional layers to capture local patterns in the data. CNN is applied to capture local patterns and features in the text data, making it effective for identifying patterns in tweets related to hate speech. The next algorithm is CNN with LSTM. This hybrid model combines the strengths of CNN for local feature extraction and LSTM for capturing long range dependencies in sequential data. It is employed to capture both local and sequential patterns in tweet text, providing a comprehensive approach to understanding linguistic features. CNN by LSTM. Similar to CNN with LSTM, this hybrid model combines convolutional layers for feature extraction with bidirectional LSTM layers for capturing both local and long range dependencies. It enhances the model's ability to capture both local and sequential patterns in the tweet text, offering a more comprehensive understanding. The next algorithm is CNN with GRU. This model combines convolutional layers for local feature extraction with GRU layers for capturing sequential dependencies. It provides an alternative to CNN LSTM, offering a hybrid approach for capturing both local and sequential patterns in the text data. The next algorithm is LSTM. LSTM, which is long short term memory, it is a type of recurrent neural network designed to capture long term dependencies in the sequential data by addressing the vanishing gradient problem. LSTM is employed for its ability to capture sequential dependencies in the text, contributing to the understanding of linguistic patterns in the tweet data. Next algorithm is LSTM with GRU. This model combines LSTM and GRU layers, leveraging the strengths of both types of usage. It is used to explore the benefits of combining LSTM and GRU in capturing complex sequential dependencies in the text. Naive Bayes. It is a probabilistic classification algorithm based on Bayes' theorem, assuming independence among features. It is often used for text classification tasks. Naive Bayes is computationally efficient and suitable as baseline model for text classification, providing simplicity and speed. Random forest. It is an ensemble learning method that constructs multiple decision trees during training and combines their predictions for improved accuracy and robustness. Random forest is employed for its ensemble nature, providing a diverse set of models that collectively contribute to accurate predictions in the project. The next algorithm is linear SVC, which is support vector classification. Linear SVC is a linear support vector machine classifier used for binary and multiclass classification tasks. Linear SVC is chosen for its effectiveness in binary classification tasks and its ability to create linear decision boundaries. Coming to random forest with SVM with naive Bayes, it is ensemble of random forest, support vector machine, and naive Bayes. This ensemble model combines the predictions of random forest, support vector machine, and naive Bayes model for a more robust final prediction. The ensemble leverages the strengths of multiple algorithms, aiming to improve overall predictive performance by combining diverse models. As an extension, we employed ensemble model and hybrid method combining the predictions of multiple individual models to produce more robust and accurate final prediction. Also, we used FLAS framework for user testing with user authentication. We have used accuracy, precision, recall, and FN score to evaluate this project. So here we have comparison graphs for all those performance metrics. This is accuracy comparison graph. Here on x-axis we have accuracy score for each algorithm and on y-axis we have algorithm names. Similarly, we will have for other three graphs also. Accuracy is the measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision score comparison graph. It is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is the recall score comparison graph. Recall is also known as sensitivity or true positive rate. Recall measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is FN score comparison graph. FN score is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in the class distribution. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file, which contain algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of codes, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup.db file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. Here we need to type the command python space app.py and then click on enter. This will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost, and the port unless configured differently. This is the localhost and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. We need to click on that first and enter all the sign up details if we are signing up newly. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. Now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here you can see a text box where we need to give the input text here. Based on the given input text, we will get the prediction whether it is hate speech or non-hate speech. So here we will give the text and now we will click on predict. Here we got the prediction as the tweet type is non-hate, which means the application has predicted the text as non-hate. Here we can see the topic for the paragraph is most dependent upon these words. Now we will give one more text. So click on home. Here we will paste one more text. I have entered the other message. Now click on predict. Here we got the prediction as the text belongs to hate speech, which means the application has classified the text as hate speech. And here we have the topic for the paragraph is most dependent upon all these words. Now click on sign out. In this way, if we give the text to the system will classify whether the tweet belongs to hate or not hate. Conclusion of the project. The primary beneficiaries of the project are users of social media platforms who often face online harassment. By accurately detecting and mitigating hate speech, the project contributes to creating a safer and more positive digital environment. Users experience reduced instances of harassment, fostering a more inclusive online community. Regulatory bodies and platform administrators benefit from the project's hate speech detection capabilities. The system provides a valuable tool for enforcing policies against hate speech on digital platforms. This empowers regulatory bodies to take proactive measures and maintain a healthy online ecosystem. The project embraces a spectrum of algorithms from advanced models like BERT to traditional methods such have been naive ways, showcasing a commitment towards diverse, a thorough hate speech detection strategies. Utilizing ensemble methods elevates predictive capabilities, harnessing the collective strength of multiple models for improved accuracy. The integration of Flask framework with SQLite for sign up and sign in ensures a secure, authenticated user experience. This contributes to user privacy and establishes a trustworthy platform for individuals engaging with the hate speech detection system.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.